This is June 2012 AS2 question 7. Okay, so this question asks us to work out the molecular formula of the compound, and just be careful to read your question carefully on this type of question to see whether it asks you for empirical formula or for molecular formula. In this case, you're asked for the molecular formula, but the first step in either case is always to work out the empirical formula first of all, and we do that using our ratios as we've done before. So we can see that the compound contains carbon, hydrogen and oxygen. Okay, and as before we can take the percentages to equal the mass of each element in the substance. So we've got 40.7 grams of carbon, 5.1 grams of hydrogen and 54.2 grams of oxygen. We then need to work out the number of moles by doing N equals mass over relative, either you can do relative formula mass or relative atomic mass, might be easier to see. So for carbon that's going to be 40.7 over 12, for hydrogen it's going to be 5.1 over 1, and for oxygen it's going to be 54.2 over 16. Plug those into your calculator and you should get that it equals about 3.39 grams of carbon, 3.39 moles of carbon, 5.1 moles of hydrogen, and 3.3875 moles of oxygen. And again, our next step is always to divide through by the smallest number, and in this case it is oxygen, 3.3875. So divide each of those numbers by the smallest number. So for carbon it's 3.39 divided by 3.3875, which is 1.00. 5.1 divided by 3.3875 is 1.5. And obviously 3.3875 divided by 3.3875 is 1. So this is an attempt to get our ratio into whole numbers, but you can see that we haven't done that. We still have a decimal of 1.5. So think to yourself, how can I get 1.5 into a whole number? Well, I can multiply by 2. And you need to remember to multiply everything by 2. So that gets us 2.00, which is essentially 2 of carbon to 3 of hydrogen and 2 of oxygen. So that means our empirical formula is C2H3O2. But we're not finished yet because we're asked to work out the molecular formula. So the next step in trying to work out the molecular formula is we need to find the ratio of the mass of our molecular formula to the mass of our empirical formula. So the ratio is going to be the relative formula mass of the molecule, where in this question it's given to you as the RMM of the compound, divided by the relative formula mass of your empirical formula. So we're told in the question that the RFM of the actual compound is 118. And then we need to divide through by the RFM of the empirical formula. Well, the RFM of the empirical formula is going to be 2 carbons, which is 24, plus 3 hydrogens, which is 3, plus 2 oxygens, which is 32. That gives you a relative formula mass of 59. So it's going to be 118 divided by 59, which is 2. What that means is the RFM of the actual molecule is twice as big as the RFM of the empirical formula. So what we do at this stage to get our molecular formula is it's going to be 2 times our empirical formula. So we times everything in the empirical formula, which is C2H3O2 by 2, which gives us C4H6O4. Just to clarify the difference, the empirical formula, which is what you can calculate by the percentages or the mass composition, is the simplest form of your formula. So the numbers, the ratio of carbon to hydrogen to oxygen, the numbers are in their simplest form, whereas the molecular formula represents the actual formula. So for example, and maybe a more familiar example would be the likes of an alkene. So let's take butene, would have the formula of C4H8, but simplify that down into its simplest form, we have CH2. But we know that we can't represent the formula of butene by CH2 because, for example, if we have propane, which is C3H6, that also simplifies down to CH2. So molecular formula represents the actual formula, empirical formula is the formula in its simplest form.